Okay, so today we will cover the next coding exercise. So the problem is, and it is on the Geeks for Geeks, and the problem is max sum array of size k. This is also like a very important question which generally ask in the interview. So let's try to understand what the question is being asked and what should be our approach. So so max sum. So we have to find the maximum sum of sub-array of size k. So as an example, so let's suppose we have four elements n is equal to 4 and one array is given. The elements are 100, 200, 300, 400 and k is 2. So we need to find a sub-array whose size is 2. So first we need to find the sub-array. So whose size is 2? 100, 200 is one of the sub-array. 200, 300 is one of the sub-array whose size is 2. And 300, 400 is 300 and 400 is one sub-array whose size is 2. But out of these three sub-arrays, whose sum is more? So if we calculate first two, so 200 plus 100, 300, 200 plus 300, 500, 300 plus 400, then 700. So 700 is our answer because we need to find the maximum sum of sub-array of size k. Right. So as an example, so let's suppose, so this is like a small array. So let's figure it out on the some big array. So let's suppose we have some array given, and this array has how much elements? Like 11 or 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. 11 element. Right. So let's write here n is equal to 11. Okay. So 11 element. And we need to and we have given size k means like the sub array like length. So k is 4. We need to find the sub array of size k means size 4. We need to find a sub array of size k whose sum is maximum. So what all or the sub arrays? So these are the sub arrays. Like first, this is the sub array. 10, 20, 10 minus 20, 30, 40. So if we calculate the sum of all these, the sum is 60. Then we can check the sum of next sub-array, minus 20, 30, 40, 50, that is 100. Then we can check the sum of next sub-array, or we can say next four elements. Then we can check the sum of next, then we can check the sum of next, and we have to run the loop till like this point, till 9. Right, because if we run our loop from here, then we don't have, like, it's like out of array because there are no four elements. All right, and we have to calculate we have to find the sub array whose size is like 4. All right, so if we have find all the sub arrays, we have find all the sum, and then we can figure it out. Okay, whose sum is bigger, whose sum is maximum. So maximum sum is 100. So we can return our output. Okay, output is 100. So, but how we can like solve it? So first approach is like the brute force method. All right. So let's try the brute force method. Even though in the question it is mentioned, if you scroll down, it is mentioned the time complexity should be O of n. O of n means like one single loop. All right, and there should not be an extra space. That is fine, but there should be one single loop. There should be no two loops, three loops, four loops. All right, but anyhow, like we will run with the single loop as well. But first, try to run with the two loops. So our approach is we need to run one loop which will run till this point, till 9, because we don't have to run the till 18, till this point only, right? Because if we run from here, then we don't have the four elements. And there is another loop which will calculate all this number. So let's suppose that there is one loop which will run to calculate the sum of four elements, right? Then the next four elements, then the next four elements, right? So like this. Okay. So first loop will run from here to here. So let's try that. So let's copy the code from here. So k is given, array is given, n is given. N is the like the size of so what are given, uh, k is given, let's suppose 4. Array is given, so we can copy this array. Array is given, and what else, n. So n is given, which is 11. So fine, what we have to do, we have to call this method maximum subarray, and we have to pass the k, we have to pass the array, we have to pass the n, and it will return the output. So let's try the first method. So that is the brute force. So let's rename this function brute force method. So what we have to do? So we have to run one loop which will calculate first these elements, then these elements, then this element, this element. Till what point we have to run? We have to run till this point. All right. So we have to run loop for I in range. So what is range? Like till what point? So let's suppose R. But what should be the value of R? So if we calculate here, so we know we need to run the loop only till this point, not here, not here, not here. Because if we run the loop from here, then we don't have the 4 elements and the k is 4. So basically the length of the array, so length of the array is 11. Okay, so we have to run a loop till which point? So what is this? We have to run the loop till this point. So what is this index? So 0, 1, 2, 3, 4, 5, 6, and 7. So till 7th index, we can say till 7th index, right? But in range, right? So generally we add +1, because if we give 7 here, then the loop will run till 6th time only. So we can say, okay, till 7th index should be 7, index should be 7, but like range should be like 8, because then only it will run from 0 to 7. So 0, 1, 2, 3, 4, 5, 6, 7. Then it will run from 0 to 7, right? So 0 to 7. Then how we calculate this number 8? All right. So how to calculate? So 11. So total number of elements 11, and if we minus k, so total number of elements 11, and if we minus k, which is 4, so what the result? 7. But we need 8, so we need to add +1. Then it should be 8. So basically n minus k plus 1. So then it will give the r value. So here r is equal to n minus k plus 1. So we need to run a loop till here. So first it will, so first the I will be this, because for this loop the I will be 10. For the next loop I will be minus 20. For the next loop I will be 30. For the next loop I will be 40. For the next loop I will be 50. Then I will be minus 60. Then I will be 70. Then I will be 9. And after that loop will be end, because we don't want to go further because there are no 4 elements, right? So one loop will be run, that is fine. So what will be the second loop? For j in the range of, so now, okay, I is this. So, but we have to run the loop till this point only. But starting from the I, starting from the I. So whatever the I is, if I is first 0, then from here. If I is 1, then from here. So whatever the I is, we have to start the loop from here. But till which point? All right, only 4 elements, so we can't write 4, because if we write 4, then I is equal to 0, 1, 2, 3, so it will read the previous elements. So basically I plus k, we can mention I plus k. So I plus k, I plus k. So let's do pass. Why I plus k? So I is 0. So 0 plus k is equal to like we can say uh, k is 4. 0 plus 4 is equal to 4. All right, so 4. And it will run till 0, 1, 2, 3 only. So 0, 1, 2, 3. So that is perfectly fine. So what we have to do, we have to calculate the sum of these elements. So let's calculate. So current sum is equal to current sum plus array of j, and let's do the current sum is equal to 0. So it will give the sum for this loop, then it will give the sum of the another loop, then it will give the sum of the next loop, then next, then next, then next. All right. So when once we have the current loop, and then it will, okay, we have calculated this sum 10 minus 20 30 40. Then it will calculate this, but we have to calculate both of the, like which one is bigger, and we have to store the value. All right. So when we calculated first sum 10 minus 20 30 40, we have to calculate with some value. So let's assign some value max sum. Max sum is the infinity. So how to define the infinity? We have to define the minus infinity. So let's, or you can say minus 99999 some number, or minus infinity. So what could be the max sum? So max sum should be maximum of current sum and max sum. Or you can like do the some if loop as well. If you don't want to do this, then you can write the if loop. All right. So basically, or you can do so for the simple purpose. If current sum, so 10 minus 20 30 40 is current sum is greater than the max sum, then our max sum should be current sum, and we have to return the max sum, not equal to, we have to return the max sum. All right, so let's try to run this. So output should be, we know output should be 100. If there is any error, we will like try to run. Okay. Solution that has no attribute maximum sum subarray. So okay, I have changed the name. So we are getting the 100 output. So let's try the with this example as well. So where array is this, k is equal to 2. Array is equal to this. Let's comment this. And k is equal to 2 and n is equal to 4. Output is 700 and it is expecting 700. So let's try some another. So array is 4, n is equal to also 4, but k is equal to 4. So k is also equal to 4. So 1000. So we are expecting 1000 only. So that is perfectly fine. But what's the issue in this code? We are running the two loops. So O of n square, but in our code, it is mentioned the time complexity should be O of n. So the single loop. All right. So if we like submit the solution, then it is wrong, because as per the ask, we have not performed the action. But anyhow, like as per the code is perfectly working fine. So let's try some another method. Def. The another method is the sliding method, which is also very important. And this method is useful in many questions. So we have to, so let's remove this and we will perform on this only. So n is equal to 11. So sliding method. So if we see this question now, from this question, we can notice one thing, like we are repeating some operation multiple times. As an example, I calculated the sum of these four elements 10, minus 20, 30, 40 by running a loop, right? And then I calculated the sum of these four elements, next four elements. So next four elements. But if you noticed, I already calculated the sum of minus 20, 30, and 40. Then why should I calculate this again, the sum of minus 20, 30, 40? If I know all this sum, I already calculated the sum of 10, minus 20, 30, 40, and which is 60. So for the next window, sorry. So for the next window, what I can do is I don't need 10, right? So I can remove 10. So 60 minus 10, 50, and I can add 50. I don't need to add minus 20, minus 30, minus 40, right? So similarly, for the next window, I already calculated the sum of minus 20, 30, 40, and 50. And for the next window, 30, 40, 50, and minus 60, I will remove minus 20 from the previous sum, and I will add the next sum, the next element. So by this approach, we don't need to calculate, because if we see, okay, k is 4, then like it is fine, like we have to operation like only 4 times. But let's suppose k is 1000. Unnecessary, we are calculating the 1000 element sum again and again and again, right? So we don't want to, like, when we already calculated all these sum, then why should we can use this like the previous sum again? We have to just subtract minus 10 and we have to add 50, because these three elements will remain same. In this case, uh 30, 40, 50 will remain same. In this case, 40, 50 minus 60 will remain same for the previous window. So we can use, so this is the called a sliding window. Sliding window means, so we have to calculate the first four elements, then we will slide our window. So there should be only one loop. We will not run the two loops. So first we'll calculate the sum of first four elements. Then we will slide our window. And as soon as we slide our window, we will decrease the previous element and we will add the next element. Then we will again slide our window. Then we will decrease the previous element and add the next element. And then we again slide our window. Then again slide our window. Again we will slide our window. Again we will slide our window, and then again. So again this time we have to run our window till only 9, because if we again slide our window, only three elements, right? So we can't slide like more than that, right? So by this approach, only single run, there are no only single for loop, there are no two for loops, right? So first we have to calculate. So we, at least for one window we need the sum, only then for the next window we can use the previous sum. So for the one window at least we need the sum. So how to calculate the the sum for one window? So for I in range of k, right? So k means 4. So for first four elements we can easily calculate the sum, right? So let's suppose uh, window sum. So let's suppose it's called a window sum. Window sum is equal to window sum plus array of I, and here window sum is equal to 0, right? So we just calculated the sum of first four elements, and then we will like remove the previous element and add the next element, right? But only single row. So we already calculated the sum of first four elements. So the first four elements has been calculated because it will run till 4. 4 means like 0, 1, 2, 3 only, because the range will not include the last elements, and k is no 4. So from 0 to 3. So 0, 1, 2, 3. So all these elements will be calculated and the sum will be stored into the window sum. And we will mention, okay, let's this is the maximum sum. Let this is the maximum sum. So maximum sum is equal to window sum, because when we calculated the next window, we have to calculate the previous window, whether the previous window sum is greater or the next window sum is greater. So that's why we are consider, okay, maximum sum is this window sum, the existing window sum. Then what next? Then we have to run a loop, right? So we have to run a loop. So loop on this window, then loop on this window, then loop on this window, then loop on next window, then loop on next window. So we have to run a loop. So loop from which index? So loop from first index, right? So for I in range of 1. So we have to start a loop from 1. But till till which element? Till till we know this element, and we already calculated how to calculate this. This is the R, n minus k plus 1. N minus k plus 1. So this element, all right? And so the current window, or we can say the window sum. So now we have to calculate. So the next loop will be run from here to here. So minus 20. So 1 minute. So window sum should be, so previous window sum minus, so previous window sum should be 60, like for this window sum, like 10 minus 20, 30, 40. Now we have to run a loop from here to here. Like we have to calculate the sum from here to here. So how to calculate? So we have to subtract the previous element. So what is the previous element? But from which we have to subtract? We have to subtract the element from this window. From this window, if we subtract 10 and we add 50, then we will get this window sum. So window sum minus array of I minus 1. I is 1 because index is 1. So next time I is 2. So we will subtract minus 20. If then we will, when the window is this, we will subtract 30. Then window is this, we will subtract this. We will subtract this. And we will add what we have to add. So we have to add, so here we have to add 50. So what is 50? 50 is at which index? So 0, 1, 2, 3, 4 is at fourth index. All right. So, but we can't mention directly 4. So how to calculate this is like I plus K. So K is capital. So I plus K is, I is like 0. I is 1. So K plus 1 is equal to, like 4 plus 1 is equal to 5, and then minus 1. So we can do that. Or is this correct, or we just need I plus K? So K is 4 and we need fifth element. 0, 1, no. So 0, 1, 2, 3, and 4. So we need fourth elements, and K is 1. All right. So K is 1. So that is fine. So 1 minus 1, 0, and then plus 1. Then we will get the window sum. Then we will find the maximum sum. So what is the maximum sum? Maximum sum is equal to max of maximum sum and window sum. And then we will return the max sum. So first it will run the loop from here to here. Then it will run from when I is equal to 2. So first I is equal to 1. I is equal to 1, it will run a loop. And in the first loop, it will calculate this sum. From the second loop, so second loop I is equal to 2 from here to here. So 2 minus 1, 1. So we will subtract minus 20, and we will add 30, 40, 50, minus 60. So we have to add minus 60. So I is 2, 2 plus 4, 6, but our index is 5. All right, so 0, 1, 2, 3, 4, 5. That's why we subtracted minus 1. And then we have to return. So let's try that. So let's change the function method only. So we are expecting output should be 100. So let's see. Otherwise, we will see if there is any error in our code. So output is 100. So let's try on some another 100, 300, 400. So let's try on some another array. Array is equal to this, and n is equal to 4, k is equal to 4. Fine. Then 1000. That is perfectly fine. If k is equal to 2, then output should be 700. Output is 700. So it looks like the code is working fine. So let's copy this code and paste here. And let's try to compile and run. So compile is fine. So let's try to submit if all the test cases has run fine or not. So all our test cases has been run fine. Like all 62 by 62 test cases has been run fine. So that is fine. Our code is working. So I will paste this link in the maybe description. So you can also practice, because this is like a great question, like maximum sum sub array of size k. So which use the concept of the sliding window. So in this case, if you see, like, even there is a one loop here and there is a one loop here, but there are no two for loops. So here k is, let's suppose, n. So one is n, O of n. Here again O of n. So only the worst case complexity of big O of n. So it's not like the next nested loops. So the complexity is O of n, and which the question only wants. So question wants is, like, we need the expected time complexity should be big O of n, and in that we are working. So you can also try this question. This is a good question, like, which use the concept of the sliding window, and this sliding window concept is used in like many questions. So let's suppose if the question is minimum sum, if you find the minimum sum, then the same thing, just we have to use the minimum here. We have to calculate, and instead of we have to calculate the minimum, but like whatever is the minimum, we will return the minimum. So this question can be changed in like in further way. The question minimum sum sub array of size k, we have to find the sub array of size k whose sum is minimum. All right, so the question can be modified in any way, but the concept will be the same. So that's it. That's the end of the video. Thank you.